By request, I'm going to show you how to graph this quadratic using a table of values. So we're going to have to apply the rules of Bedness to generate our table of values. So on our table of values, we're going to have a set of x and y coordinates. And for our x values, we'll use -2, -1, 0, 1, 2, and 3. We'll just go with those. So to start out, if x is -2, then y is going to be 3 times -2 minus 1 squared plus 2. So all I'm doing is I'm pulling x out of the equation and I'm putting -2 in its place. To find the y value, that's going to go here. So I've got to do what's inside the brackets first. I've got -2 minus 1, which is -3. So I've got -3 squared times 3 plus 2. Now I'm going to apply my exponent, so I'm going to square it. -3 squared is +9, so I've got 9. And that 9 is multiplied by 3, and I've got to add 2. 3 times 9 is 27, and when I add 2 to that, it's going to give me 29. Okay, now we're going to do the same thing, but when x is -1. So if x is -1, y is 3 times -1 minus 1 squared plus 2. -1 minus 1 is -2. So I've got 3 times -2 squared plus 2. Now remember, we applied the brackets first, and after we apply the brackets, we apply the exponents. -2 squared is 4. So I've got 3 times 4 plus 2, which is 7. Sorry, that's 3 plus 4. It's 12 plus 2, which is 14. So if x is -1, y is 14. Now, we'll deal with it if x is 0. If x is 0, y, we just replace x with 0. Y is 3 times 0 minus 1 squared plus 2. 0 minus 1 is -1, so we have 3 times -1 squared plus 2. -1 squared is +1, so I've got 3 times +1 plus 2, which is 5. So when that's a 0, that's a 5. Okay, now if x is equal to x is equal to 1, we've got y is 3 times 1 minus 1 squared plus 2. So this one's interesting. 1 minus 1 is 0. So we have 0 squared times 3 plus 2. 0 squared is 0. 0 times 3 is 0. So all of that is a 0 plus 2. So that's just equal to 2. If x is equal to 2, if x is 2, y is 3 times 2 minus 1 squared plus 2. So it is 3 times 2 minus 1 is 1 squared plus 2. 1 squared is 1. That's 3 times 1 plus 2. And that's equal to 5. See how we've gone up to 5 again? Now remember, these parabolas always come out symmetrical, so at this point we can anticipate the next number should come out to 14, but let's just verify. If x equals 3, y is 3, and then we replace x with 3. 3 minus 1 squared plus 2. 3 minus 1 is 2. So y is equal to 3 times 2 squared plus 2. 2 squared is 4. So I've got 3 times 4 plus 2. 3 times 4 is 12. So I've got 12 plus 2, which is 14. So my y values are 29, 14, 5, 2, 5, 14. And you should always see a pattern emerge where it's symmetrical. If we go to 4, we know ahead of time that's going to give us a 29. So now when it's time to graph this on a Cartesian plane, if x is equal to 1, y is equal to 2. So that's a 2, that's a 1. If x equals 0 or 2, y is equal to 5. So that's a 5 here. And if it's a 2, that's a 5 there. And if it is 3 or negative 1, it goes all the way up to 14. So these dots here are at plus 14. I'm not going to fit the 29 on here. Make sure that bottom is rounded, not pointed. And connect your dots. So that's how you graph y equals 3 times x minus 1 squared plus 2 by generating a table of values. We're putting in our x values from minus 2 to 3. And then one at a time we take each of those x values and you plug it in to replace x with it. And then apply BEDMAS. So you do brackets, then exponents, then division, multiplication, then addition, subtraction. And check against these numbers to make sure that you're calculating that correctly.